I'm Anil Kumar, and in this video we'll discuss characteristics of linear functions. In fact, here we'll discuss linear functions which are represented by slanting lines. So lines which are slanting, what I mean to say is that the lines could be going upwards or going downwards, right? So they may slant up like this, or they may be slanting downwards like this. So we'll consider characteristics of linear functions which have this kind of characteristics. And in the next video, we'll consider characteristics of linear functions which are, I should say, linear relations which are horizontal or vertical. Okay. Now, when we talk about characteristics, there are so many things which we should include. One of them is so whenever we are talking about characteristics of any function, there are a few things which we should include. They are like domain, range, interval for increasing, decreasing, positive, negative, and we have intercepts. So when we say intercepts, then there are x-intercepts and y-intercepts, and we should also include end behavior. So these are the characteristics which we should consider when we look into characteristics of any function for that matter, right? So we'll consider all of them one by one. Now, as far as the domain is concerned, for both these lines, whether they are increasing or decreasing, we know x belongs to real numbers. There are no restrictions, right? So x belongs to real numbers. Range, we know y belongs to real numbers. X is the independent variable and y is the dependent variable. X-axis represents the independent variable, y-axis represents the dependent variable, right? And we are considering lines which are not going through origins. So it is a special case where the lines are not really going through the origin. Now what we notice here is interval for increasing is always increasing, right? So in this particular, it is always, right, increasing, and decreasing, it is never increasing, never decreasing. But if the line is slanting downwards, in that case it is always decreasing. Do you see that? So, and it is never increasing, right? So let me write never increasing. Okay, as far as domain range is concerned, you know, both belongs to the real numbers. Now, when is it positive and when it is negative? In the first case, for the line to be positive, we can see it is on the right side of x-intercept. So we can say right of x-intercept. In this case, it is on the left side of x-intercept. Negative, the line is negative when it is on left of x-intercept, and in this case it is on right of x-intercept, correct? Intercepts, it will have one each, right? It has one x-intercept and one y-intercept. End behavior. When we talk about end behavior, we need to consider what happens when x becomes negatively large. So I'm writing negatively large with negative infinity. We see y also becomes negatively large, and when x becomes positively large, y also becomes positively large, right? So it is in the same direction, right? So it moves from quadrant, you can see, from 3 to 1. So it moves from quadrant 3 to 1, correct? In this particular case, When x becomes negatively large, y becomes positively large. As x approaches negative infinity, y approaches positive infinity. And when x approaches positive infinity, y approaches negative infinity, right? So this particular line, which slants downwards, moves from quadrant 2 to quadrant 4, correct? So these are the characteristics which you should discuss when talking about lines. Now, I'll leave this special case for you. Now, special case, let me write full form. Special case is when the lines are going through origin, right? So special case is when the line pass through origin, right? That is to say, what happens to the characteristics, how the characteristics will be different when we have a case when the line is increasing, was going through the origin, right, like this, or when the line is decreasing and going through the origin, kind of like this. Do you see that? In that case, what you notice is that all these characteristics remain same. However, what you find here is that x and y intercepts are at origin, right? So x and y intercepts are at origin, and you can see, since the intercepts are at origin, the line, the sign of the line changes as it crosses origin, right? So as it crosses origin, the sign changes. Domain, range, all of the things kind of remain same, right? So that is how you could explain the characteristics of linear functions. Now, in the next video, we'll talk about characteristics of linear functions, which are represented by horizontal and vertical lines. So we'll consider horizontal and vertical lines in the next section. Okay, so this is what we do in the next video. I highly appreciate your time. You can now watch the next video to understand characteristics of linear functions when they are represented by horizontal and vertical lines. I'll again make a correction here. Both of these lines may or may not be functions. We'll see which one is not a function, but both are relations, of course, in the next video. I hope that helps. Thank you and all the best.